My name is Snir. I work at Next Insurance as a data engineer, and I'm going to talk to you today about a project we call DAGLint, which is basically using automated linting to achieve Airflow DAG quality and standardization across our instance. Okay, so today we're going to go over the challenges we had with maintaining DAG quality at scale. Then we're going to deep dive into our solution and the architecture and some code. Then we'll talk about the integrations we made with the tool, what we were able to achieve, and hopefully we'll have some time for questions and answers. Okay, so I think some of you, or maybe most of you, can relate that DAGs at scale can become messy for multiple reasons. But I'm going to highlight some of the reasons we found hard to tackle. And the first one is inconsistencies. So we have a lot of engineers in our group, and lots of DAGs, and we found out that slowly, as the team grows, the style of those DAGs are starting to diverge, and we have no real standards. So it becomes really inconsistently, and when you go and take a look at someone else's DAG, then it becomes like something entirely new to you. Another issue we found out was hidden anti-patterns. Those are maybe do not involve standardization, but can really hurt your Airflow instance. Anti-patterns that can slow your scheduler or can reach avoidable costs and slowly finding their way into your repo. And it creates maintenance hell. Debugging becomes too hard when you face another one DAG that you are not familiar at all with how it is written. Maybe it has some issues that cause your Airflow to, I don't know, the DAG to disappear or not to be able to import. And it also delays all the processes. PRs are getting slow because we are focusing on those anti-patterns and trying to find those issues. And also onboarding new engineers also becomes a mess because they need to get familiar with all the different things that are going on. So let's have an example here. So we have a very simple DAG, one task saying hello world to the log. But it's written in 3 different ways. We have the traditional syntax, we have TaskFlow API that people find attractive, and also we can also have like hybrids. We have traditional syntax, but this time we don't want functions to be inside the DAG file, so we import them. And this is just like all 3 variations are all valid, but they are very different than each other and can become harder to predict when you take a look at new DAGs. Another pattern we wanted to avoid, and we found very hurting what we define quality, is that DAGs are not documented or they are not using tags. Since we have lots of DAGs, we rely on DAG tags to navigate our way through the UI, and without them, if people are getting their way and getting new DAGs without tags, it's really making it hard to navigate. And also, if the DAG is not documented properly, then it means we don't have an owner, we don't know who owns the DAG, what's the playbook to run it manually, or what's the playbook to handle any issues, and basically what's the purpose of it. So this is also a thing we wanted to be avoidable at all costs in our production instance. And finally, those sneaky anti-patterns I mentioned, I think the most famous one is top-level expensive code running. And since the way Airflow is being built, then it means that every time your DAG is being imported, either by the scheduler or the worker pods, then it means your DAG is also being executed. So if you have a very slow or expensive code running there, then this can be a real issue on your scheduler and the instance health. Here I have a very exaggerated example that I'm opening a DB connection every time the DAG is being parsed. And you can imagine if this database is not available, then this DAG is also not available. So what we tried to fix this issue. So we tried training sessions, but as time goes, so does knowledge fade, and people tend to forget what they went through training sessions. Code reviews also, while it kind of works, it can lead to inconsistent enforcement because some people can just forget to review those things. So it really were inconsistent and time consuming. Documentation, of course, everyone knows that it becomes stale very quickly and no one likes to read it nor to write it. And monitoring the performance for those sneaky anti-patterns, while it works, it is a reactive approach. So if we know there is an issue, it's already affecting production. And we wanted to avoid that before it happens. So what we really wanted is to have something automatic that will prevent those issues from going into our production instance, and that we don't need to do anything about it or for it to be time consuming. So this leads us to the tool we developed. We called it DAGLint. It's basically a linter for Airflow DAGs. It runs locally on terminal. It's fast and deterministic. And its goal is to identify and prevent those anti-patterns or code smells that are specific to Airflow. And it provides a clear and useful output for the developer to fix any issues he might come up with. So let's dive deeper, and as we progress through the layers, we'll see more and more technical details and code. So I hope you can bear with me after lunch. So the first layer is the command line interface. This is the main entry point for the developer to interact with the tool. It's a simple command line interface command. You just write DAGLint, you provide a path to your DAGs folder and the name of the DAG. You can also choose to lint all of your DAGs or even lint specific rules for a specific DAG. So this is nice. It provides the output, and we'll see it soon. But how does it do it? So the next layer is the engine. It's the brain itself. And in a nutshell and in a high level, what DAGLint is doing is basically walking the DAGs directory. It identifies those files that are DAG files and not just any other Python scripts you might have there. It lints the DAG file or files you requested. It knows how to respect comment-based exclusions, so sometimes you want to exclude certain checks from certain DAGs because you know it's the right thing to do. And finally, it provides a scoring mechanism, so you can really get a grade per DAG and know where you stand in terms of quality per DAG and per team and whatever slice and dice you want to do with it. Okay, so how does it do it? I'm getting there, I'm promising. So in order for the engine to lint the DAG, it needs to know what rules it needs to enforce. So those rules, we created a framework, and we split those rules into 3 different types. We got organization rules. These are more naming conventions, making sure task IDs and variables are matching by name. We found it helpful. File organization, we want every DAG to be in its own subfolder, and every module of it and every SQL file will also sit there because it's easy for us to track. The second category is structuring rules. It's more about how the DAG is being written. So we prefer traditional syntax at Next. So we wanted DAGs to be defined using context managers and using certain operators and not others. We didn't want any function definition or business logic in the DAG file because we wanted it to remain like a configuration file. And the last type is code quality rules. Those are the anti-patterns we just mentioned. Also things that we define as quality, like a README file that exists as a docmd attribute, and basically any other rules that checks for quality. So what a rule is. So a rule, basically, in order to define a rule, we created an abstract class called lint rule. What this class is defining as a rule is basically that it needs to have a name, a description, and an ID. And most importantly, every class that inherits from lint rule must implement the validate method. And the validate method is basically where all the magic happens and where we check those conditions that we want to enforce. Another thing, thanks to that inheritance, DAGLint, the engine itself, can find all those rules and register them automatically just by the inheritance. So it's really making it easy to add rules without ever being considered with how the engine works. So those validation logic are written using Python AST, and I'm going to explain a bit about what Python AST is so we can understand how to write validation logics. So AST is a built-in module of Python. Python uses it to basically read, parse the code, and inspect it without executing it. So it is fast, it is safe, and you don't need to rely on any string manipulations or regexes, God forbid. And how it does it? It creates a tree structure out of your code. So every structure in your code becomes a node in the tree. And we can take a look at an example, a very simple one. We have an assignment statement to the right, x equals 5 plus 3, and basically what AST is doing is creating a tree out of it. So the topmost child of the tree, or the root of the tree, is the assign node type. It has 2 children, children nodes, the target node, which is X, because this is the result of the assignment will go into X, and the value itself is also a complex node type of binary operation. Binary operation has itself 3 child nodes, the left side of the binary operation, the operator itself, which is plus here, and the right side, which is 3. Okay, so this is great, we have a tree, but how do we really use it in order to find those rules or those violations? So in order to understand how we do that, we need to understand what's node visitors here. So AST provides a class called node visitor, which basically implements a method that traverses the trees for every type of node. So we saw before we have an assign node, so there will be a visit assign method. We have the binary operation node, so there will be a visit binary operation method. And using those methods and by overriding them, we can create our own node visitors. So let's take a look at a simple example here. Let's imagine we want to count how many function definitions we have in a Python script. We can do it naively using regex and string manipulations, but it will be both slow, inefficient, and maybe we'll get it wrong. So instead, we can use what Python is doing and utilize the AST module. So how we do it? We create a class called function counter. We inherit from node visitor, and just from inheritance, we turn our class into a visitor. So it already knows how to traverse this AST tree. We set a counter to count the number of function definitions we encounter. And finally, and most importantly, we override the visit function def method. This method, when we override it, we know that we are traversing the tree and we just got to a function definition node. So since we know we got to a function definition, we can increase the counter by 1 and call generic visit to continue visiting other child nodes. That way, we can traverse the entire tree, and when we are done, we are getting the result we want, which is the number of function definitions. Okay, that is great, but we are in Airflow conference. So let's take an example of how we can implement an Airflow violation rule. So to the left, I have the same DAG I had before. It doesn't have the docmd attribute, so we can think that it is not documented. So, and we want to catch those DAGs that are not documented. So what we do, we create a class, inherits from node visitor, and it turns out all we need to do is to override the visit call method. The call method is being called every time that there is a function call. And also when you instantiate a DAG object, it calls the constructor of that class. So it is also a function call. So once we are in a visit call method, then we know that we are traversing the tree and we just found a function call, and we just can now ask questions that that we can make sure that we are in a DAG instantiation function call. So this is how the code is written. Here I'm just printing if I found a violation, but you can imagine in real time what we do is raise an exception, catching all those exceptions, and then we get the score that we need. So this is how we implement one rule. You can imagine you can implement whatever rules you want using that as long as you know which methods to override and what violations are you looking for. So once we got the AST out of the way, and we can discuss how it is being visualized and how the output is for the developer. So the first thing he will see in his terminal is the score for the DAG. He can immediately see that his DAG is not matching the standards. He's only got 73%. He has a table with all the different rules we have set, and either if it passed it or not. He can, of course, also provide flags to the terminal to see only the failed rules or whatever. But also, if the same rule are being violated more than once, we also provide the developer with all the line numbers that this violation happens. And we can do it easily using AST. It provides us the line number. So it's really easy for the developer to come and fix that. Okay, that's great. We now have a tool that have rules and the developer knows the score, but how can we use it in order to really elevate our DAG's quality and also make sure that those sneaky issues are not getting into production? So This leads us to the integration parts. And first, and the most important thing for us to do is to integrate DAGLint as part of our CI/CD pipeline. In order to do it, we created a GitHub action that runs every time there is a new PR opened, and it looks for specifically DAG files that were modified. Because if a SQL file was modified, we don't need to run DAGLint. So if we find any DAG files, then we can run DAGLint on it. And if there are any issues or any rules are being violated, then we just block the PR. And the developer is now blocked, and he cannot continue until he gets a perfect score, or if there is a good reason for exclusion. So doing that, we achieved uninterrupted code reviews. We no longer need to look for these issues when we review each other's codes. And also, we can be sure that our main branch is green and consistent. This is how it looks like in GitHub. To the left, you can see the different steps that the GitHub action has. We can also see that the action prints or commented on the PR with the score of that DAG, which is perfect. And also, you can see that the check that prevents failures from being merged into production passed, so we can merge this PR. We also wanted to integrate it with monitoring and analytics because we wanted to have a score for the DAG, but also for the team, and making sure that our group maintains that score and just make it go up and not go down. So what we did to integrate it with Tableau, this is our visualization tool, we created a Jenkins pipeline that runs daily, and it just lint and scores every DAG we have in the system. It also knows to by using tags, it knows to which team belong the specific DAG. And we persist those results daily in Postgres table. Then this table feeding the dashboard that you can see here. So we can see over time the different scores, and to the top right, you can also see that we are splitting it by teams. So it becomes kind of a game we have on Mondays that we see what's the score for each team and who beats who. Before I wrap up, I also wanted to mention that as we started using the tool, we found creative use cases for it outside standardization. So we had a very big project. We have a custom operator we built for data quality. It connects to your talk from before. And we wanted to replace it with a new version, but we wanted to do it gradually. So the thing with gradual migration is that you can get regression. When you already migrate a DAG to the new version, someone can accidentally take it back to the previous version, or even introduce new DAGs that use the old version. And then by creating a rule that this allows the usage of the old operator, we made sure that every PR opens with a DAG file containing this old operator will not be able to be merged, and then we force the migration on this DAG. So finally, we can discuss what we achieved. And to the right, we can see that once we launched DAGLint, we had a group score of 66% of compliance. And over a few months, and we could see from the chart trend that we could make it also consistent, we raised it up to 98%, and we never went down from it since then. And we got lots of new DAGs into. So what we were able to achieve with that? The developer productivity went up. We no longer needed to focus on these things. It automatically enforced for us. And if we forgot something and made a mistake, then DAGLint made it clear to us what we need to fix. The code reviews are no longer focusing on those anti-patterns and those issues. Ops and compliance got improved because now we can have a metric for quality of the DAGs and what we defined as quality DAGs. And new engineer onboardings are very simple because we don't need to have a lot of sessions on how our DAGs should look like. It just automatically enforces the new engineers to use our patterns. So with all these achievements, we were able to achieve quality enforced at scale. And yeah, if you're interested or knowing more, there's a Medium article with the same name. You can scan the QR code and it will lead you directly to it. It's hosted by the Apache Airflow Medium space.